Hello my dear students, I will take some more examples on springs. Let us take this example. A closed coiled helical spring has mean diameter of 75 mm and spring constant of 80 kN per meter. It has 8 coils. What is the suitable diameter of the spring wire if maximum shear stress not to exceed 250 MN per meter square? Modulus of rigidity of the spring wire material is 80 GN per meter square. What is the maximum axial load the spring can carry? So here given the diameter, mean diameter is 75 mm, so that is capital D. So capital R is 75 divided by 2, that is 37.5, and spring constant that is K or S is equal to 80 kilonewton per meter. Okay, the number of turns that is N is equal to 8. It is asked to calculate what is the suitable diameter of the spring. D you have to calculate, and tau is equal to 250 meganewton per meter square, or 250 into 10 raised to 6 Newton per meter square. And modulus of rigidity of the spring wire material is 80 giganewton per meter square, or 80 into 10 raised to 9 Newton per meter square. What is the maximum axial load the spring can carry? That is W you have to calculate. Okay, so what we have the formula T is equal to tau into pi divided by 16 D cube. Right, and also T is equal to WR. In the last class I have shown that formula. So if you substitute T is equal to WR here, T is equal to W, R is equal to actually 37.5 millimeter. So convert into meter. You can keep in millimeter also, not a problem, because here this is in meter, so I use in meters only. Okay, so this becomes 0.0375 meters is equal to tau is 250 into 10 raised to 6 Newton per meter square into pi divided by 16 into D cube. D we don't know, we have to calculate. Okay, so here two unknowns are there, W also, D also, so we cannot continue this. It is difficult to solve this two unknowns. So what we can do, we have one more formula, that is deflection is equal to W divided by K or W divided by S, stiffness. So you can write in terms of W. What is W? So W is equal to stiffness into deflection, K into delta or S into delta. Okay, so W is equal to, we have the value of K, right, it is given here spring constant, that is 80 kilonewton per meter. So 80 I have converted into all Newton and meter, so 80 into 10 raised to 3 Newton per meter into deflection. Deflection we don't know. How we can calculate deflection? We have formula for deflection, that is equal to 64 WR cube N divided by CD raised to 4, right? So substitute here 64 into W we don't know, like that only you write, into R you have R value, that is 0.0375 cube into 8 number of turns divided by C. C is equal to 80 into 10 raised to 9 into D raised to 4. Okay, so simplify this and write like this. Okay, now you can substitute. We have this equation, W is equal to K into delta, or W is equal to 80 into 10 raised to 3 into delta. So substitute this delta value in this equation 2. Okay, so substitute delta in equation 2. So what we will get, W is equal to 80 into 10 raised to 3 into 33.75 into 10 raised to minus 4 into W is we don't know, divided by D raised to 4. Okay, write in terms of D raised to 4, you get this, simplify this, take the square root of D, so you get D is equal to 12.8 mm or 0.0128 meters. Okay, so whatever the unit you can use, either meter or millimeter, but finally the answer you will get the same one. Okay, like this you can calculate what is deflection, what is the diameter. Now you have to calculate the axial load also. How you can calculate? We have this formula, right? W is equal to 80 into 10 raised to 3 into delta. So if you can substitute, or you can directly use this formula. Okay, W into 0.0375 is equal to 250 into 10 raised to 6 into pi divided by 16 d cube. So we want W, so take all this to down here, it goes here, and d, we have d value, that is 0.0128 cube d to the power 3. So you get W is equal to 2745.2 Newton. Okay, like this you can calculate what is the load and what is the diameter. I will take one more example. A closely coiled helical spring of 100 mm diameter is made of 10 mm diameter rod and has 20 turns. The spring carries an axial load of 200 Newton. Find the maximum shear induced in the section of the rod. If modulus of rigidity C is equal to 84 GPa, find the deflection and stiffness of the spring. Okay, you have to calculate what is the deflection and the stiffness. Okay, see what is given here. The capital D is given, that is 100 mm. So R is equal to 100 divided by 2 is equal to 50 mm or 0.05 meter, and small d, that is equal to 10, and number of the turns is equal to 20. The load is given 200 W, and C is equal to 84 into 10 raised to 9 Newton per meter square, and that's it. So you can calculate what is the deflection, right? You have the deflection formula, or first what you can calculate, you can calculate shear stress. You have shear stress formula, tau is equal to 16 WR divided by pi d cube. So tau is equal to 16 into W is 200 into R is 50 mm or 0.05 meter divided by pi into D. D is what is the diameter? D is 10 millimeter. So you can convert into meter, 0.01 whole to the power 3. So tau is equal to 50.93 into 10 raised to 6 Newton per meter square, or 50.93 Newton per millimeter square, or 50.93 meganewton per meter square. You can write in terms of any unit. Next, you have to calculate the deflection. Deflection, direct substitution. You have formula, deflection is equal to 64 WR cube N divided by CD raised to 4. So deflection is equal to, substitute this 64 into 200 into 0.05 whole cube into 20 divided by 84 into 10 raised to 9 into 0.01 raised to 4. So you will get deflection. Once you know the deflection, you can calculate stiffness. How you can calculate stiffness? Stiffness K or S is equal to W divided by delta. We have W value, that is 200 Newton divided by delta. Delta is equal to 38.09. Simplify this, you get 5.25 Newton per millimeter. So like this you can calculate the different terms. Main thing, you should know the formula properly. If you know the formulas properly, if any term is asked, you can able to solve you can able to get the answer. Okay, so concentrate on each formula, each relationship. Then that's it. Okay, thank you.